Alright, hello students! This is for the Lab 2 for Physical Geology 1. We are going to be going over today the physical properties of minerals. But you have a special twofer because this will also count for Lab 3. We will be doing much of the same in the third lab. So what you learned today will translate over into Lab 3. So this will be a tandem lab. So let's start off with opening to your lab manual, page 15, and we are going to begin by talking about what a rock is. Now this might seem like something that is very easy to describe. I can hold up these two rocks right here and you might just say, well, Mr. King, they're a rock, and you'd be right. But what is a rock? What defines a rock? Have you asked the rock how it is today? Well, we're going to. All right, so a rock is defined as an aggregate of minerals. An aggregate of minerals. Those three words have so much definition behind them, but they are a collection. That's what an aggregate is, a conglomerate. You might have used the term congregation. This also counts to count for a bunch of minerals just all put together into one thing to create this. All right, so what does that mean? What does that mean? Well, turn to page 16 and you will find that there are a few details that are outlined about what a rock is, and I would like to talk about the fact that there are three ways to identify a mineral. Minerals are inorganic. They are inorganic. There are no organic substances inside of a mineral. Additionally, they have a defined chemical composition. So what this means is if you have a mineral that is made of one thing, right, and then you somehow fundamentally change it, it becomes a different mineral. Even if you change something extremely minuscule, it stays, it will become something different, because if it does not stay the same, you will identify it as another mineral. It might be something very closely adjacent, but it will be different. Additionally, they have a defined crystalline structure. A defined crystalline structure. So this means that if you were to get a look at the makeup of this under a microscope, you would see that certain minerals have different makeups, different shapes that help bring them together to create the rock, the aggregate. So, all right, so again, to review, minerals are inorganic. They have a defined chemical composition, and they have a exact crystalline structure, and if that crystalline structure or the chemical composition changes, it becomes a different rock altogether. All right, so we're through that now. Let's cross that off here. All right. Okay, so now you are going to see on page, let's flip to 18, we're going to jump ahead here, the physical properties of minerals. And there are many different ways to do this. Of the ones that are listed here, I believe there are 9 or 10. We are not going to be able to do them all because they won't let me have as much fun as I possibly could by giving me acid to play with rocks. But, all right, so we're going to start with color. We're going to start with color. So to talk about color, I want to bring out my friend sandstone here. All right, so sandstone, this is red sandstone. And as you can tell in the name, you might not be able to see this too clearly, but hopefully you can at least see the color. Red sandstone is defined by its color. It's defined by its color. There are many types of sandstone, but this is its color. All right, so that means that you can look at one type of rock or one type of mineral and get an idea for what that is. Here, let's take pyrite. Let's take pyrite here. Pyrite has a very golden texture. This is often referred to as fool's gold. And you can tell that you'll look at this and you will say this is either gold or fool's gold. And most likely it's pyrite. So, all right, so be sure to look at the color. When I ask you to identify a mineral, give me its color. Tell me what it looks like. This is one of the easiest answers you can possibly give me. All right. Now we're going to go on to hardness. Now we're going to hardness. Okay, so we need to make the distinction between hardness and density. We will get to density later. But hardness is defined as how brittle the rock is. So what I want to do is I want to show you here are two rocks. Here are two rocks, right? And one of these is remarkably hard, and one of these is not. So how would we test this? Well, empirically speaking, I could take them and smash them together, and you might have seen some of the pieces fly off of this one right here, which tells you that this rock is harder. Well, about 100 years ago, there was a guy named Mose, turn to page 19 in your lab manual, who came up with a scale. And this scale is somewhat subjective. When I say subjective, I mean he started off with a fingernail and a knife and some glass. And given the sheer amount of minerals that there are, this doesn't exactly give you something exact, but it's pretty widely accepted. You can get a pretty good idea for what a mineral is by using this scale. But he started with, as I said, using a fingernail. He went on to using a knife and then a glass plate. And then he realized that he could no longer chart the hardness of something with anything man-made. So he did what you just saw me do. He smacked them together. And that can tell you that this is not nearly as hard as this. This is very brittle. And this is very solid. Okay. All right. So flip to page 20. Flip to page 20. Oop, I'm not following my own thing here, so color. Hardness. All right. So now we're going to talk about luster. Luster. This is another very easy thing to identify a mineral by. So let's take fool's gold again. I know you guys can't necessarily see this too closely. And this little sample of bauxite right here. So fool's gold, the pyrite, is very shiny. It catches the light. It's very pretty. It's a very nice sample. Where bauxite, on the other hand, looks like somebody threw it in the dirt, rolled it around and left it there, maybe let it catch some mud, and it does not catch the light. So what this tells you is that the pyrite is metallic. The pyrite is metallic. And you will see that there are two different subsections of luster, and that is metallic substance, but the bauxite is not. So what does this tell us about the bauxite? Well, you have 6 different types of non-metallic luster. So this non-metallic luster, you would look under the 6 types, and you may need to refer back to your lab manual when you do this. And you will see that this is very earthy, very earthy. It's dull and has nothing going on, like kind of boring, as it says in the manual. It is like dirt. It just isn't very nice. And you will find some others. The adamantine one, like diamond, we don't have one of those. But all right, so there is luster. Remember, luster is all about how it catches the light. So be sure to, when you look at that in the lab, understand how that works. Okay, so next we're going to go on a streak. We're on a streak. So occasionally you will find a rock, a mineral, and what you can do is you will notice that if you take that mineral and you streak it against something else, you might find some strange properties. So here is, I'm not going to say what this is just yet, but I'm going to take it and I'm going to streak it against a streak plate. So, and the streak plate, I know you might not be able to see this, this gray rock streaks red. All right, so what does that mean? Well, streak means that there is the outside of the rock may not exactly belie what the rock actually is. This is a great way for us to be able to see how the composition of a rock is not always readily available by just looking at it. The color might not always tell us what we need to know. So you might rub it against a streak plate to see, and typically, when you see something streak red, you tend to have some kind of iron involved. That's a piece of magnetite. So, all right. So when we do the labs, you will probably see me take a few samples and rub them against a streak plate. And I will have you tell me whether that matters or not. All right. Okay, so we talked about hardness before, but now we're going to talk about density. So the specific gravity of something, that's a very roundabout term for something very simple. We're on page 21, by the way. You might have seen that I skipped crystal form. Sorry, page 22. All right. the specific gravity is a way to measure the density of a rock. A lot of times you will see a scientist that will do that by using water, by putting a rock into water. So you will have certain samples that are not nearly as dense that might float, and some that won't. So again, like this giant rock here, I can assure you this is not going to float. But I have a sample of porphyritic rhyolite here. This is an igneous rock we'll get to later. That, if put in water, is extremely light. It's extremely light, and therefore not very dense. Not very dense at all. All right. That is something you probably will not see me do in the lab, but it's still a very important way to identify. We're going to backtrack here to 21. I see that I have forgotten something. I did not put it on the board. All right. So, we're going to get to cleavage and fracture. Cleavage and fracture. All right. So when I took these two rocks, I'm going to use this since this is my hardness scale. When I took these two rocks and I smacked them together, perfect. You will see that this rock breaks in even planes, right? This one in particular breaks in even planes. I have little sheets, right? Here, let me show you another one here. These are kind of neat. I have a rock here that looks like plastic. And when you break it, it comes off in little clear sheets. It fractures. Sorry, it cleaves. I'm so sorry. It cleaves. But if I were to take that sample of rhyolite that I showed you, and again, we're going to use our friend, this giant rock here. The pieces that come off of this do not cleave. They fracture. They break. They are jagged. Whereas the other objects that I have broken against this rock, they cleave because they have even planes, right? So during the lab, which I will make a video for, you will see me take rocks, and I will probably do exactly what I just did, and you will have to tell me whether it cleaves or fractures. And I will show you the result a lot more clearly than what I have now put on the Martin Hall floor. Okay, so moving along, we're going to talk about, we're through most of these now, the reaction with hydrochloric acid. I do not know why they chose this particular acid. All I know is that they will not let me play with this, and that is no fun. So what this means is they will take a bit of hydrochloric acid and put it on the mineral and see how it reacts to that. And apparently that one in particular will give you more diverse reactions among minerals. But as we are not going to do that, and again, they just won't let me have fun, we're not going to talk about that too much. Okay, so now we're going to talk about the last ways to identify a mineral, at least for us. So at the bottom of page 22, you see taste and smell. Taste and smell. All right, so I do not advise tasting every rock you find, but smell can help. For example, I had a bag of yellow rocks that I was tossing around to my students last semester, and no, it's not kryptonite. It was something that I wanted them to have a more tactile experience with because these yellow rocks stink. And I had one of my students who was brave enough to take it out and lick it, and I can promise you that it was terrible. So, yes, you can identify a mineral by its taste and smell. If you're wondering, the rock that I gave him was sulfur. It did not smell or taste any good. All right. Okay, so that is it for this lecture. So from here, you will have to do the lab that I'm going to post here a little bit. And what I will do is I will either have a video or some pictures of some minerals, and I will do some experiments on them. Maybe hitting them against the large rock here, telling me how they cleave and fracture, tell me about their color, their luster. Maybe I'll take a light and put it on it and see if it catches the light. And in addition, I told you this was a twofer. Lab 3 is all about mineral identification. We are going to take what we have learned here and apply it. And while this lab I will want you to just give me certain properties. I will probably ask you for just a little bit more out of the third lab. I'm not going to record a video for the third lab. There is so much overlap between the two for the time being that I am going to just give you a lab 3 here in a few days. Lab 2 is due Sunday. Lab 2 is due Sunday. Please do it. If you have not done lab 1, you need to get with me. You need to come talk to me. Lab 3 will be due Sunday, a week from, like, not this Sunday, but next Saturday. All right. That is everything I have. If you have any questions, please feel free to email me, and thanks for watching.